Scientists don't know what is life, they know how to recognize it. These are very two different things. Scientists are trying to build life, not clone it, not modify it, build it completely from scratch. If they succeed, what exactly have they created? A machine? A chemistry? A life? One of the scientists leading this work is a researcher named Kate Adamala. She built what are called protocells, synthetic cells assembled from non-living components. Lipid membranes, chemical reaction, information carrying through molecules. None of it was harvested from bacterium. None of it was copied from yeast. It was constructed piece by piece, boundary by boundary. And here is what troubles me about her work. It is not that she might succeed, it is that do we know what success would even look like? We have no agreed upon definition of life. Biology have proposed dozens of criteria: metabolism, reproduction, evolution, compartmentalization, information processing, but none of them draw a clean line. Viruses reproduce, but they need host. Crystals grow, but they do not evolve. Fire consumes energy, but it does not learn. So, when does life begin? Does it begin at the cell? At the molecule? At the moment when chemistry becomes sufficiently complex to pretend it has intelligence? Oddly enough, one of the things that made me think about this question was a video game. Look closer. Most of us grow up believing life is obvious. You are alive, a tree is alive, a rock is not. The distinction feels natural and even inevitable. But biology has never been comfortable with it. The more precisely we define life, the more expectations we create. The boundary keeps moving. What seems like a clear threshold becomes a gradient, a slope, a slow transition from chemistry to complexity to something that looks back at you. This is not a failure of science. It might be the failure of our assumptions. We assume life is a category, a switch, on or off. Perhaps it is not. Perhaps it is a process, a negotiation, something that accumulates rather than arrives. And if that is true, the question is not what is life, the question is what has accumulated enough. Kate Adamala works in what it is called bottom-up synthetic biology. Most biology is top-down. You take something that is already alive, a cell, a bacterium, a virus, and you study it, modify it, and you ask how it works by taking it apart and hoping it still functions when you reassemble it. Bottom-up biology does the opposite. It starts with nothing alive, lipids, nucleoids, aqueous solution, and it asks, what is the minimum system that behaves like life? How few components can you assemble before something begins to metabolize, to divide, to respond, to persist? Adamala's protocells are not alive. She would be the first one to say so. They do not have the complexity of a bacterium. They cannot survive outside a controlled environment. They are approximations, sketches, the architecture drawing of a house that has not been built yet. But they are unsettling approximations because it blurs the boundary we thought was firm. A protocell has a membrane, it has internal chemistry, it can exchange molecules with its environment under certain conditions. It can even divide implicitly, crudely, but divide. It does not know it's dividing. It has no intention. It's chemistry following physics following thermodynamics. But so, arguably, you are. That is what Adamala's work suggests. Not that protocells are alive, but that the distance between non-life and life may be much shorter than we imagined. That life may not be a miracle inserted into matter, but a property that emerges when matter is arranged with sufficient complexity and sufficient patience. What this science demonstrates is elegant and precise. We can build systems that mimic cellular behavior from non-living ingredients. What this suggests? It is more disturbing. It suggests that life was never a special case. It was simply chemistry that kept going. Look closer. I want to show you why this game made me think about Kate Adamala. Not because it is scientifically accurate. It is not. The creatures in class do not obey Earth's biology. They breathe atmosphere we could not survive. Their cells, if they have cells, would not function under terrestrial physics. But look at them. Look at the skull, it's elongated, yes, but not for style. The elongation creates leverage for muscles that need to grip, not bite. Imagine trying to eat with your face 6 feet longer than your eyes. Why evolve that burden? Because something in this world rewards it. Because the physics here, the food sources here, the competition here selects for it. Look at the spine. It curves in a way that is inefficient for a biped but perfectly calibrated for a quadruped that carries most of its weight forward. The shoulders are higher than hips and is not a design choice, it is physics. This is what happens when a body evolves to dig or to push or to lower its head for longer periods. Look at the feet, splayed, almost paddle-like, with joints that rotate further than a mammal joint should. But look at the ground, it is soft, uneven. The creatures even disturb its weight across the surface as it shifts. Those feet are not weird, they are the solution. Look at the skin, you can see where growth happened quickly and where it stalled. You can see where the creatures rubbed against stone, where parasites attack, where old injuries held into ridges. This is not detail for the sake of detail. This is detail as a memory. The creature carries its past on its surface. This is not a monster, this is not an organism. And the difference is the difference between something that was built and something that was edited. Notice this? The creatures in class do not look like they were drawn by an artist asking, what would look cool? They look like they were shaped by forces asking, what would survive? The distinction is everything. Emergence is the idea that complex systems arise from simple interacting parts. No single neuron knows it is thinking. No single ant knows it is building a colony. No single cell knows it is a liver. But put enough of them together with enough time, with enough feedback, and something appears that was not present in the individual components. Life in this view is not property, it is relationship. Cells relate to cells, organisms relate to organisms, ecosystems relate to ecosystems. At each level, new properties emerges that cannot be predicted from the level below. Consciousness emerges from neurons, evolution emerges from reproduction, plus variations plus selection. Ecosystem emerges from competition plus cooperation plus time. Evolution does not create perfection, it creates compromises. A spine that is good enough for walking but not ideal for running. Eyes that are good enough for this light would fail in another. Body that is a collection of temporary solutions to a problem that no longer exists, layered on top of each other like a geological structure. Look at the class game, the asymmetry, the inefficiency, the beauty of functions under constraint. This is what evolution looks like, not optimization, negotiation. There are studios that ask, what monster would look cool? Ace Team seems to ask, if gravity was slightly different, what would survive? Ace Team Jasilian studio that has been building worlds this way since Zero Class in 2009. Their entire catalog is sustained argument against visual language of Western fantasy. No elves, no orcs, no dragons ordered from catalog. Instead, Rock of Ages, which and where history becomes a physics toy. Zero Class, where familial trauma expressed through creatures that look like they birthed from a fever dream rather than concept meetings. They draw from South American surrealism, from the visual logic of dreams, from the refusal of intimate Tolkien template that has dominated the fantasy of half a century. But here is what I think they were actually doing. I think they are editing instead of designing. Designers build, evolution edits. Those are not the same act. Evolution is an editor, not an artist. When you build, when you start interaction, you imagine the final form and you construct towards what you edit. You start with variations, you select against failure, and you do not know what you are making, and you only know it has not yet died. Ace-Team's creatures feel like edited because they feel like solutions to problems we cannot see. The skull is elongated not because it is striking but because it solves something. The feet are splayed not because of distinction but because it distributes weight. The asymmetry is not decorative, it is a function. This is what happens when artists think like naturalists. They do not ask what would look cool. They ask what would grow here. And the same question evolution asks, is why class feels alive. I have been avoiding this title. Class, Artifacts of Chaos. Chaos is a loaded word. In common uses, it means disaster, destruction, randomness, the opposite of structure. But in biology, chaos is something else. Life exists because order emerges from chaos. Cells divide imperfectly, mutations arise randomly, most of them fail, some of them succeed, and one that succeeds becomes the new baseline, the new organism changes, the new ecosystem changes, the world changes. Chaos is not the enemy of life, chaos is the engine. Mutation is the chaos, adaptation is the order that crystallizes from it. Identity itself, your identity, the creature's identity, the world's identity. It is not fixed thing. It is temporary resolution of a chaotic forces. A shape that holds just long enough to be recognized before the chaos resumes. The title then is not warning. It is a description. Artifacts of chaos are not relics of destruction. They are evidence that order is always provisional. That every creature, every structure, every self is a mandatory agreement in universe that is constantly renegating. Kate Adamala's Protocells are artifacts of chaos. They are imperfect membranes, imperfect chemistry, imperfect divisions. They are what happens when you let molecules interact without a blueprint, without intention, without a designer's hand. And the unsettling thing is, they look familiar. So, if science eventually creates a functioning synthetic cell, what changes? Did humanity create life, or we simply discovered another path towards it? This is the emotional center of this essay, not because it is sad but because it is unresolvable. Everything I have told you so far, the science can back it up. But what comes next is just me thinking out loud. If life is a category, a switch off on and off, then creating synthetic life is a miracle. It is Prometheus stealing fire. It is a moment when chemistry becomes sacred. But if life is a process, if it is a gradient, if it is chemistry that has accumulated enough complexity to persist, then creating synthetic cell is not a miracle. It is a demonstration, a proof that the boundary we imagined was never really there. Kate Adamala's work does not prove that the life is meaningless. It proves the opposite. It proves that life is not special in the way we want it to be. It is not a gift. It is not a soul inserted into matter. It is the matter that has learned to organize itself well enough that to keep organizing itself. And if that's true, then the most important question is not, is it alive? The most interesting question is, Why did we ever think life had a sharp boundary? Look closer. The creatures in class feel alive not because they resemble Earth. They feel alive because they resemble evolution. They carry their history on their surfaces. They solve their problems with compromises. They are asymmetrical, insufficient, beautiful in the way that function becomes beautiful when understand the constraint. Perhaps life is not something we recognize. Perhaps life is something we negotiate between molecules, between cells, between organisms, between ecosystems, between chaos and order. Which means maybe we have never actually been individuals. Maybe we have only ever been agreements.